So here we need to prove the following. So let's begin with part 1. So we'll start from the left hand side. So on our left hand side, we have the derivative with respect to t of our vector A dotted to vector dB over dt minus where vector derivative of vector A with respect to t dotted to vector B. So this is equals to, now we'll take the derivative with respect to t of each of the two terms. We have vector A dotted to dB over dt minus derivative with respect to t of dA vector over dt dotted to vector B. Now here what we'll do, we'll apply the product rule to each of the two terms. So we'll first begin by taking derivative with respect to t of vector A, and this will be dotted to dB over dt, plus we'll keep the vector A aside and then we'll dot it with the derivative with respect to t of dB over dt. Similarly, we do that to our second term. So we have negative times, we take the derivative with respect to t of dA vector with dt and dot it to vector B, minus we have dA vector with respect to dt and take the dot product with the second vector, which is dB vector over dt. So here what I have been doing is using the property that if we have ddt of two vectors, A vector dotted with B, so first we'll take the derivative of A with respect to t and dot it with vector B, and in the second we'll take A vector and dot it to derivative of B with respect to t. So this is what we have been doing so far. Right. So let's write it down. Now we will see that the first term and the last term cancels out because they are exactly the same. So we're left with only the second term and the third term. So that means we have vector A dotted to, so we have to the derivative with respect to t of dB over dt. So that means this is the second derivative of vector B with respect to t, minus, so here we have second derivative of vector A with respect to t dotted with vector B. So this is what we are asked to prove. So that we have taken care of part 1. So let's prove part 2. Proceeding in the same way as the previous problem. So we'll start from this particular side. So this will be derivative. So let me write down what we will do here. So if we have the derivative with respect to t of the cross product between the vectors A and B, so this will be dA vector by dt crossed with vector B plus A vector crossed to derivative of vector A with respect to derivative vector B with respect to t. So we will do that. So first we will take, well, let's break it down. So we have derivative with respect to t of vector A crossed with vector dB over dt minus derivative with respect to t of dA vector over dt crossed with vector B. So this will be, so first we'll take derivative of vector A with respect to t and then cross it with vector, the second vector, which is dB over dt, plus we'll keep the first vector aside, which is vector A, and cross it with derivative with respect to t of dB over dt. So that's actually the second derivative of B with respect to t, minus, now we'll again apply derivative of the cross product. So this will become derivative with respect to t of the first derivative of A. So that means we have second derivative of A with respect to t crossed with B, minus is coming because we have a negative sign here. So we have derivative of A with respect to t crossed with derivative of B with respect to t. So luckily the first term and the last term cancels out and this leaves us with our result, hence proved.